Guys, today we're gonna be solving right here. Kodo eating bananas. Let's go ahead and try to solve it. We're given an integer array called piles, okay? And piles I is the number of bananas in the ith pile. We're also given the integer h, which represents the number of hours we have to h is equal to hours we have to eat all food. Okay. And then we have to eat all of the food in piles at the I is the amount of food in that pile. We have to, the piles don't carry over. Basically, what this means is that if there's one pile, if pile pile I is equal to, let's say, 2, but then my eating speed is, let's just say it's like 10, right? Um, then it takes 1 hour to finish that pile. Same thing if my eating speed is, let's just say if it was 1, if it was 2, then then it would still take 1 hour to finish. You know what I mean? So that's why it says if pile has less than k bananas, see right here. Okay, let's see. Okay, let's go ahead and write out how we're going to solve this problem. So we could tell that the fastest we could ever eat is the max of the pile. And we could see that right here, actually, in the second example. You see, we only have 4 hours to eat everything in this pile, so the maximum eating speed that we could necessarily have is 25. We could have something more, but it's kind of pointless because we're trying to maximize our efficiency, if you know what I mean. So yeah, we could go ahead and just kind of write that variable out. Get the biggest pile. Now we, all right, we could assume that we know that the lowest piles, that the speed, the eating speed is less than or equal to the max pile. All right, so we could go ahead and do that by doing max eating speed. Actually, let's call it right. Right pointer will just equal to max of piles. And then let's just say the left pointer is equal to 1. And it's equal to 1 because if our eating speed is 0, we could never finish all the bananas in that pile, right? So by having left pointer 1, we have just anything, right? Any speed. It's like the slowest speed that we could eat at to finish all these piles. But now we have to hit the condition if it even reaches H because we only have 4 hours to eat everything, right? If we ate everything at speed 1 banana per hour, this would take forever to finish. And that's definitely going to be bigger than hour 4. So that's how we know that yeah, we have to have a condition. Go ahead and write that down. We have a condition where our current speed must, just say must, be faster than h. Right, faster or equal. Okay, now we could just have that. Let's go ahead and compute actually the middle. We can compute the middle. And how can we do that? We could just say, while left pointer is less than or equal to the right pointer. Then we go ahead and run this loop. And where do we run the loop? We run the loop on um Yeah, we run the loop on just basically the range of runs the loop for 1 through max. But yeah, max power, we just call it right pointer. Let's just call it top eating speed. All right, there you go. That might make more sense. Okay, that might make more sense for some people, so I'm just gonna name it that. And we want to see, we don't want to find the slowest eating speed we could eat, but still hit this requirement. You know what I mean? So let's go ahead and find the current eating speed. Current eating speed could just be equal to slowest plus top eating speed. Let's divide this by 2. Now we gotta have kind of like an hour counter to see how long we have actually taken. So let's just say our counter is equal to oh if we could compare it to the current pile, so we could say um we gotta think of a mathematical equation. Let's go ahead and think of it. So we have piles, which is our current pile. So we say current eating speed. We have to divide by current eating speed. Let's say we could get the piles at this pile. Oh yes, exactly. We have to do for piles for pile and piles. We go ahead and compute the hour counter. So this is basically how many hours we've already used up. So hour counters is plus equals. Hmm. Okay, for example, let's say if we eat at a speed of 2, it'd be 4 divided by 2, but we have to actually get the remainder. So for each pile in piles, we should just compute that current pile, the current pile. How do we get the current pile? We do piles, current. Wait, no, we could just call piles. Pile plus, we want to use the upper ceiling, so we could do piles plus, um, plus current eating speed, and then minus 1. This is the same thing as ceiling division, and we divide this by the current eating speed. Okay, okay, so after doing this, we can see that ah, we can see how long it took for us to finish all the bananas, all the food. I'm just gonna say food because bananas kind of takes a bit longer to spell. Now we kind of compare this hour counter Well, we see if our counter is actually less than, let's just call this answer. Let's call it slowest eating speed valid, right? We have to check if it's valid. So if our counter is less than or equal to, H was the number of hours we're given to actually eat all the bananas. Oops, let's call it H, okay. Then we could go ahead and update our slowest valid eating speed. We could actually set this to, we want it to be something like infinity. And let's go ahead and do this. So let's do minimum, or actually let's go ahead and copy this, right? Because if this condition is satisfied, then we know it's a valid eating speed, right? And if it's not, then we go ahead and change it. But let's go ahead, slowest eating speed valid is equal to minimum of that and the current one, which is hour, or which is actually going to be current eating speed. Okay, this is pretty good. But we also want to see if we could get something better. Can we get a better solution? Something eat even slower, but then have enough time to actually finish in time. So we could do that by how do we eat slower? We could eat slower by actually de-incrementing the right pointer. So we could decrease our top eating speed is equal to, let's say, our current eating speed, and then subtracted by just say 1. Okay. There's also else our counter. Let's say if our counter is fast, and so that's this condition right here. Let's say if our counter, our output, this is our hour counter. Let's say if it was bigger than h, so this means it's valid. If it's greater, that means it's not valid. That means we ate too slow. We ate too slow, not valid, right? And this is, let's go ahead and put a comment. We ate too fast. Can we do better? All right, so what happens when we eat too slow? Well, then we're gonna have to eat faster, right? How do we eat faster? We could increase the slowest eating speed and make it quicker. So we could say slowest eating speed is equal to current eating speed. Just say plus equals 1, right? Because we want to increase our speed. And then from there, we should have a good amount, or we could have the slowest eating speed, which is valid. And we computed every single possibility using a binary search, which is more efficient. And we could just return the slowest eating speed valid. And let's see if we got this correct. And looks like I did a mistake right here. So current eating speed, just plus ones. I don't know why I put it equal. Let's go ahead and run it again. And let's see what's wrong right here. So slowest eating speed valid is equal to slowest eating speed valid. Current eating speed. Some sort of misspell here. Hmm. Hmm. Um, let's go ahead and check the output. Okay, so comparing infinity. I think I haven't seen anyone use infinity with these double quotes. Maybe it's that, but I thought in Python it should be the same. Let's go ahead and check. And we got a wrong test case. Um, oh, okay, there you go. I had to actually put float. I'm wondering, would it work if I use integer? I guess it's only for floats. Yeah, it's a syntax issue, but that's how you solve Kodo eating bananas. I hope you guys understand the theory behind it. That's how you solve it. Thank you guys for watching.